and I am currently a senior DevOps engineer. A large part of my role is working with Terraform, building infrastructure as code, and then also working on demonolithing large monolithic Terraform repositories into smaller microservice-oriented repos. So I'm here to share how we demonolith a repo and also some best practices and tips that you can use when building out your Terraform repositories. So I guess we can start with, hopefully everyone here is familiar with Terraform. Terraform's an infrastructure as code tool, and that is created by HashiCorp. It uses the HCL configuration syntax, and yeah, we use it to create resources in different clouds, like if you want to create EC2 instances as code and things like that. So, does anyone know what this is? Exactly. It's a badly AI generated picture of a monolith. So what is a Terraform monolith? Does anyone know? So a monolith is a Terraform repo that houses multiple component code bases in a single repository. You might have heard this referred to as like a mono repo also. Basically, everything's in one repo in a monolith. And so when we use this architecture, our state file starts to grow in size as we add more and more resources to our repo. And so eventually, when we grow to, I don't know, 50 microservices, every time we execute a plan or apply, it's going to take longer and longer because Terraform refreshes the state of every resource in the repo. So every time we're adding resources on top of this, it's just growing in time for our CI/CD process to complete. And so traditionally, most companies start out with a mono repo or a monolith. And this is because they're trying to get started creating infrastructure fast. Like when you're a startup, you want to get going, get off the ground as soon as possible. You might not even be a DevOps engineer, and you might get asked to write Terraform code. So for the most part, when a company is getting started with Terraform, they're going to go with the monolith repository structure, at least if they've been using Terraform for a while. Modern Terraform kind of says not to do this, but you'll probably still run into this everywhere. And so historically, the mono repo or monolith repo structure got broken down by environments, usually separated by separate directories. And so recently, with the popularity of microservice-oriented applications, which is we've got one microservice performing one function as part of our application, it's kind of becoming the industry standard to break down this repo into one microservice per repository. So the repo will house that microservice, any code that goes along with it, any like CI/CD resources, and then also the Terraform resources that belong to that microservice. So basically, what to take away from here is that a monolith is a repo that houses everything in a single repo. And when you do that, it's going to grow out of control as you add more and more resources to this repo. So you can kind of see where I'm going. As your organization grows, this becomes unmanageable. So next question. How many microservices do you think Uber has right now? Anyone? Imagine having this all in a single repo. It's not manageable, right? So you can kind of get the idea, like as your organization grows bigger and bigger, you got to start thinking about how to solve these things. Yeah, exactly. And they deploy these things multiple times a day. Pretty crazy.
Wow.
So, trends we're seeing in Terraform. More companies moving away from monorepo or monolith repo structure. We're seeing less and less people use that. Companies continuing to break their Terraform code bases down into microservice-oriented repos. Sometimes when you do this, it can even lead to you noticing like, hey, this repo is too big. Why do we have 1,000 resources for this microservice? And that can even lead to you breaking these down further into more microservices. And the last one, which I'll come back to later, I'm seeing less companies using Terraform modules and sticking to simple repos that are just using resources. It seems like when you start creating modules for reusable resources, this can also grow out of control. And eventually your company has a module for every single AWS resource that you could possibly use in the repo. So that obviously also greatly increases the complexity in your Terraform repo. And asking a new developer to go in there and read this stuff can be hard to get going. So sticking to a simple structure where you're only creating resources and not child modules can be very valuable. And finally, it seems like a lot of companies are moving towards a team structure based on microservices. So instead of just having like a generic development team, each microservice is going to have their own team. And inside that team, there's going to be developers, DevOps, and it's their responsibility to own that microservice which they work on. So moving to this new repo structure, it's going to make it easier for you to give ownership of the Terraform code base for a microservice over to the microservice teams. And obviously, this is going to make your developers more self-sufficient. If they can take ownership of that code, they're going to be able to easier work on it and contribute to it. So next, we're going to look at some examples of repo that we're taking from monolith over to demonolith. So first, how does a monolith repo start out looking? So in this example, you can see on the left, well, I guess this isn't clear yet, but it will be. So this is a repo that houses 6 microservices. This is, let's say we're just coming into a job. This is commonly what you'll see. And so all 6 microservice resources are going to coexist in a single main.tf file in the root of the directory. Now, in addition to this, all 6 microservices in that file are going to have their resources directly referencing each other. So to give you an example of that, say each microservice has a secrets manager resource that we create to pass into the application. And we might have one resource, or sorry, we might have one microservice that has an RDS database. With this structure, they're going to be directly referencing to all of these resources in that file. And what this does is it creates dependencies between every microservice's resources. And so what this leads to is that you can't easily remove a microservice from that file because it's got a direct dependency on some other resource in the file. So this is going to make it very hard to break it down, but usually this is where we start. And so it's not uncommon to see most organizations start with this structure. Everything gets thrown into a single TF file. And they do this to get off the ground running and creating infrastructure fast. And eventually you're going to grow tired of looking through a 500, 600 line file, trying to find a resource or looking for what's referencing a resource in there. So what's the next step and how do we break this down further? So the first step, which I like to take, is you're going to open that main.tf file and identify which microservices live in there. You're going to do that by looking at all the resources in there and identifying the list of resources that belong to each microservice. And then we're going to split that out into its own file. Now you can see on the right side, instead of just a single main.tf file, we've got this broken out into 6 microservice.tf files. So this is a good first step because, excuse me. So this is a good first step because it's going to allow you to at least target your deployments. So you can target one of these TF files and say, I want to deploy microservice 1 or microservice 6. So that's one advantage this gives you over having a single main.tf file where everything lives. In this example, we can also see that we've got modules that live under the modules directory, and these get shared by all of our microservice.tf files. But what happens when we grow to 50 or even 100 microservices? Do we really want to maintain 100.tf files, all the variables that go along with it, and then also a set of modules that can be used by 100 different files? I hope we don't want to do that. So there is a better way. So I guess when would you want to ever use a monolith repo? I can think of 2 situations where you'd want to use a monolith. One is if you're a startup and you want to get going fast. So often when you're in a startup, there's going to be blurred responsibilities. So you might be a developer and get asked to write Terraform. You might be a DevOps and get asked to write code. Like, it goes both ways. So if you are a developer getting asked to write Terraform, that's like a situation when you'd want to use a monolith. You probably have other responsibilities. You want to get going fast, go with the monolith. Keep it simple until you grow beyond the means that this can support. The other situation I can think of when you would want to use this repo structure is if you're a small company with a small number of resources, I wouldn't make things more complex by breaking it down into a demonolith structure. Like if you don't even have microservices, this might not even make sense. I always lean towards keeping the repos as simple as you can. So if this makes things more complex, don't do it. So this leads us to our next question. How do we demonolith our monolith repo? So I like to tackle these in several phases. We're going to start at the beginning. We'll say that we've got a monolith repo where all of our resources for our microservices are stored in a single main.tf file, like the first example we saw. So the first phase, I would say, is what we just looked at. You're going to want to identify the resources and break every microservice's Terraform resources out of the single main.tf file into its own .tf file, and you can name that whatever. And so keep in mind, we still have a monolith repo at this point, but this gets us moving in the right direction. And it's going to make it easier to move each microservice into its own repo. And so after breaking the repo down into separate TF files per microservice, then we need to think about the next phase, which is going to be splitting our code base into one repo per microservice. So what does our example look like after the demonolith happens? So these are separate repos we're looking at right here. And we can see that each one has its own repo now. It's got a single main.tf file. which is going to contain the resources that are associated with that microservice. In addition, we can see that in our modules folder, we're only pulling in the modules that we need there. We're not pulling in every module. This should improve readability, make it less complex, and slim your code base down. So yeah, like I said, you can see our microservices have been demonolithed into separate repos. Microservice 1 has been split out alongside all of the module resources that it uses, which is EC2, ELB, and Route 53. And on the other hand, microservice 2 has been split out alongside all the modules it uses, which is Redshift, RDS, and S3. So each repo only contains the modules it requires. And with this structure, each repo is able to operate independently of our other microservices. This is going to make our Terraform code base easier to maintain, and each code base is going to be small and easy to read. With this repo structure, we should also notice our CI/CD speed improving. There's less resources to refresh and deploy each time. And in addition, we're only targeting the resources our microservice needs, which is going to reduce the blast radius that can potentially hit other microservices. I think so. I think you can use like a Git submodule, and what that would allow you to do is house all these modules in a separate repository and then link that submodule in each of your microservice repos. That would probably be the best way to share the modules with all of your repositories. So what's our next step? Oh, sorry, went back too far. Okay, so what benefits does this give us? The big one is faster CI/CD runtimes. Personally, the place I'm working now, we've got a monolith structure that has, let's see, probably 100 microservices in it. And the reason we had to demonolith is because Jenkins started taking 30 plus minutes to refresh our state. So obviously this is not good, and our developers don't like waiting that long for their code to build. So breaking this down is going to give you much faster runtimes, and you're not deploying the whole code base at once. You're deploying smaller chunks that are faster and more concise. Obviously, yeah, smaller Terraform code bases are going to plan and apply faster. This is going to be easier to manage. We now know where to look if we need to find a microservices code. With the monolith structure, you're often looking through a single file that has everything in it, and that's never fast. You've got to find stuff. If you touch one resource, you might indirectly affect another resource if it's referencing that. So this is going to be easier for us as DevOps to manage. And then finally, I mentioned this earlier, if you're using a microservice-oriented team structure at your work, this is going to make it so each team can now own their own Terraform code base, and your devs can contribute there. So yeah, this means each development team can now add or remove Terraform resources for the microservice they own without affecting any other microservices code base, which would happen in a mono repo or monolith. So how can we take this one step further? We can break our microservices down further into more microservices. Maybe microservice 2, we realize is 2 microservices, and we can split it out into 2 new services. We can also get rid of our modules. I personally don't like using modules. I'll explain more on that in a bit when we get to best practices. Without modules, our repo is now more readable. We only have 4 files per repo to maintain. This is a huge improvement over what we had before, and we're not sharing modules or maintaining a set of modules that our Terraform repos pull in. And yeah, as I mentioned before, we can deploy each of these separately without having to target anything or worry about blast radius hitting a different microservice when we deploy that. So let's recap the phases that we need to take in our demonolith. So a rough outline of the phases in a demonolith. First, you want to identify all the microservices that live in your monolith repo and identify the Terraform resources belonging to the microservice. When you do this, you should also identify what other microservice resources reference these resources. So that's a big part, identifying the references. And let's see. Oh yeah, okay. So step 2, when you break out all the microservices you've identified into their own TF file, you're going to want to take this time to remove all of the direct references to the resource and replace them with data sources to indirectly pull the needed information. So let me explain more on that. When you directly reference a resource from another resource in Terraform, you're creating a hard dependency between those two resources. The better way to do this is to use a data source to look up the information you need. And the reason for that is the data source looking up the information is going to decouple that dependency, and you're using an indirect reference at that point, and that's going to make it much easier when you need to break these resources out into their own repo, because there's nothing directly referencing it. This might not make sense now, but when I show you an example repo at the end, I'll show you an example of this. Step 3 is we're going to break out all of our microservices into their own repositories. Each of the new repos that we create should only contain the Terraform resources required for the microservice to run. Should have nothing else. Keep it directly focused on the service that lives in that repo. And finally, step 4, you should be demonolithed at this point. So I would take this time to remove additional complexity in the repo by not using modules. Keep a simple repo structure that's easy to read and fast to deploy. Are there any questions on the demonolith part of this? I mean, it's kind of personal preference. Like, I've seen it both ways, where there's a repo with centralized Helm charts and manifests. And then I've also seen it where the microservice repo has the application code, Kubernetes manifests, Terraform resources, and CI/CD resources all in one. So I guess there's not really a best way to do that. It's personal preference. So personally, I like keeping a repo with the Helm charts separately. That's how we manage all of that at the moment. Personally, I think data calls are going to be the best bet, because when you rip it out, then you can just take the data call with the code into the new repo, and that data call is going to look up what you need. All right, so now I'm going to get into some best practices and tips. So I'm going to talk about how to structure the Terraform repo. when should I use modules, when should I not use modules, and then some additional best practices and tips. So how should I structure my TF repo? So at minimum, HashiCorp Terraform best practices says every repo should contain 4 files in the base of the repo. And this is considered the root module. Any modules you create under this are going to be considered child modules that you're pulling in. So these are the 4 files that you should have. First one is main.tf. This is going to create any configuration or Terraform resources. One important note is that when you look through the Terraform documentation, they're going to reference this file often, but there's nothing saying that you have to have a single main.tf in your repo structure. You can have one or more .tf files in the root folder, and they'll all be executed when you do a plan and apply. Outputs.tf, you always want to have this defining output values. Output values are really good for validating resources. You can tell, you can have an output for a module, a resource, and it will show you what's being output by that resource or module. So if you need to validate something is being set correctly on a resource or module, you want to put it in outputs. Terraform.tf, so the documentation generally refers to this file as a single file that's going to contain a Terraform block, which has your providers, the required version for Terraform, all of your backend configurations saying that you want your backend stored in S3 or wherever, and any state locking configuration you have set up. I've also worked at places where I've seen this called other stuff like providers.tf, but this is what you'll see this referred to as in the Terraform documentation usually. And finally, variables.tf. This is going to house your input variables that get consumed by Terraform resources or modules. Okay, so child modules, when should we use them? So I think I briefly mentioned, but modules that you create under the root of the directory are known as child modules. So generally we use those to create reusable resources. So for example, if you know you're going to be spinning up 100 EC2 instances, you would create a child module for EC2, and then you don't have to create 100 resource blocks for this module specifying all the variables and whatnot. You would just create a reusable child module and call that. So when you would want to use those, I personally think you should use a module if you're creating more than 5 instances of a resource. So if you find yourself repeating yourself, like maybe you're creating ALBs for a microservice and you know you're going to need more and more and more ALBs as you scale up, create a resource and save yourself some time. But on the other hand, modules make your code base a lot more complex for multiple reasons. So the first one is that instead of having a direct resource where you can see all of the input variables that go into it, you're going to have a second level of modules that you're calling. And if you need to look up a problem with a resource, you're going to have to look in 2 places. First, you're going to have to find where the module is being created, and then you might also have to look inside the module at the resources the module is creating to debug this. So in my opinion, always lean towards not using modules if you can. Just use straight resources in your repo. Personally, I try not to use these, but there is like unavoidable times where you don't want to write out 100 to 300 Terraform resources, and this would save time, and that's when you would want to use a Terraform module. So on the other hand, when should you not use modules? Don't create child modules if you have a simple Terraform code base with a small number of resources. So in this instance, simple means that you don't have a large number of resources like Uber. If you've got 100 Terraform resources, I don't think you need modules. On the other hand, if you've got 1,000 Terraform resources and you've got 100 RDS instances that are going to be there, then that's a case where you would want to use them. And so, as I mentioned earlier, most organizations that I've talked to or heard of are moving away from using modules. And the thought is that each microservice should only have a small maintainable amount of Terraform resources. And if you need modules, there's probably a high chance that the repo you're looking at needs to get broken down further into separate microservices. And so if we want to add a child module, how do we do that? Personally, I like to create a modules directory like we saw in the examples earlier. Inside the modules directory, you'll typically group these by if you have AWS and other cloud resources, it would be something like modules/AWS, modules/GCP. And then to break it down further under these folders, we would have something like modules/AWS/EC2 and group our modules in this fashion. And so when you create a child module, it's going to be very similar to the root of the directory. Each module has to have 3 files in it. The one that we do not need in a child module is terraform.tf, and that's because your child modules are going to inherit the provider configuration from the Terraform TF file in the root directory. So when you create a child module, it should have 3 files, main.tf, which is going to have the resources and configuration for the child module, outputs, which same thing as the root directory. This has outputs for the resources that your child module are creating. And finally, variables.tf, which is going to have the input variables for your child module. So some best practices. First is Terraform workspaces. So if you're not familiar with what Terraform workspaces is, I like to think of it as the Terraform equivalent of a Git branch. So when we start a new GitHub repo, we've got a main or master branch, and then we can create branches off of that, like dev, QA, or whatever. So similar with Terraform, we start with a default workspace, but we can also create separate workspaces inside of our repo. This is powerful because it lets you create separate backends for your dev, QA, or production environments in a single repo. So I think this is a very useful tool if you're looking for ways to segment your repo and deploy to different environments. If you look into Terraform workspaces on the Terraform website, it shows you how to create a workspace or automate this process, which can be done by setting an environment variable at runtime to the workspace name that you want to run in. And so that can provide a good bit of automation in terms of your Jenkins pipeline can utilize workspaces to deploy to different places. So if you want to deploy to dev, QA, or production, you can use workspaces for this. Another best practice, which I mentioned earlier, when you're working on a large Terraform code base, avoid creating resource dependencies. And so what I mean by that is use data sources to reference things instead of directly referencing the resource itself. This is going to make it easier for you to refactor the code later, and it's going to avoid creating direct dependencies between multiple resources. Another best practice is going to be but try to avoid using child modules if you can. It seems like a great idea at first. It worked great for us at my current job, and then eventually we had a module for everything in AWS. Like any resource you can think of, we had a module created for it, and maintaining all of that was a nightmare. Let's see. Another good best practice, which Terraform is going to recommend about child modules, and if you look in the documentation, is that child modules should never be a wrapper around a single resource. Your child module should create a group of resources bundled together that all interact with each other. So a good example I like to think of is an ELB module. If you were to create that, it wouldn't just be a single resource in the module for the ALB. You're going to want to bundle the ALB, the listener rule, maybe even the certificate alongside that. And so a couple tips: keep your Terraform code base small, simple, and concise. Avoid using modules. Ideally, your repo should only contain the Terraform code base for the microservice being housed in the repo. The next one is good to mention because it can save a lot of time. So you can use for each loops in Terraform code to avoid repeating yourself. So the way this would work is that you can loop over like a JSON object that has multiple blocks in it and create multiple resources from that JSON block. This helps you avoid repeating code in your repo. You can use a single block to create multiple resources. Next one is going to be always use data sources to indirectly reference another resource. This is going to reduce your direct dependencies, and it allows you to easily decouple the code base if you need to. And finally, make sure you use Terraform backend state locking. I've seen multiple disasters. People didn't have this, and if you don't have that, multiple people can run Terraform against the same state at once, and that's going to lead to your state getting corrupted, and that's not going to be fun to recover from. Yeah, so that's a good call out. I personally use ZSH for my shell. And so they've got a Terraform plugin there. And so what that does is when you're in your terminal and you're in a Terraform repo, there's a very visible block on the line that says exactly which workspace you're in. Okay, so we've got a few more minutes, so I'm just going to show you guys an example of what I was talking about. So all right, here's our step one in the demonolith. So this is where we have everything in a single main.tf file. Imagine having to read this. There's 6 microservices living in the same file. And anytime you need to manage this, you're going to have to come into this file, find what you need, and edit it. Now, the direct references I was talking about, in this example, each microservices has a secrets manager secret, and that contains values that it needs in it. So an example of a direct reference would be, we see right here, we're pulling db.url, and this is directly referencing the AWS DB instance resource called data manager and pulling the address off of it. So if we look for this in our file, we see this resource here. And so we're directly referencing this resource, and that's creating a dependency between the secret we were just looking at and this DB instance resource. Now, in step 2, we'll see that this gets removed and replaced by a data source. So let's look at step 2. This is where we split out all 6 microservices into their own file, still a monolith repo structure. So if we look in here, here we go. So this is our secret for the front end, and we see that we are using a data call instead of directly referencing the database resource and pulling it from there. Data call gets created in this file, and that's just another secret that is created by a different microservice that we are looking up using this data source and indirectly pulling the value into these 2 config settings. So demonolith, after we break them all into their own repo, we'll notice main.tf only has the resources associated with the microservice. In this case, it's the front end, and our file is now only 75 lines. And then finally, at the end, the last example, we've got no more resources in here. We've got no more modules in our repo. Everything is a straight resource, and we're not using any modules whatsoever. Yeah, I think that's pretty much everything I wanted to show. Any questions you guys have? All right, well, if nothing else, thanks everyone for attending.